Okay, thank you everyone for joining us on this webinar. My name is Vikram and I am our sales director. I am joined on this webinar by my colleague Mike Yang, our senior engineer. Today we are going to tell you about our ability to generate thousands and thousands, hundreds of thousands of phone calls over IP TDM and analog networks. So the title of this webinar is called High Density Call Emulation over IP TDM and Analog Networks. So let's go ahead and get started. Um, I think I see a lot of you in the attendee list, and I think a lot of you are familiar with who we are. But in case you are not, we are GL Communications. We've been around for over 35 years. We're located right outside of Washington, D.C. We also have a development office in Bangalore, India. We are a telecommunications consulting firm. We do a lot of custom hardware development and custom software development for the telecom industry. We make test and measurement equipment for all sorts of different networks, IP networks, analog networks, T1, E1, fiber optic networks, wireless networks, including 3G, 4G, 5G, land mobile radio networks, and so forth. So we basically, any sort of telecommunications network, um, we have test equipment for it. And we can test these networks, we can load test these networks, we can test them for voice quality, data testing, and all these other different types of stuff we can do. We can generate traffic onto these networks, we can monitor traffic onto these networks. So generate traffic and monitor traffic on these networks. We can also capture and store long-term traffic coming from these networks. So that's a little bit about us. Okay, so I mentioned that we can generate hundreds of thousands of phone calls onto telecommunications networks. And so we call this load testing. And first of all, who would actually care about this? So there's a lot of different entities that will care about load testing telecom networks. First off, are service providers. Service providers are the ones that are providing either internet or voice communications circuits or whatever they may be. Um, and these service providers, they must load test their networks in order to assess the reliability of their networks and identify performance bottlenecks and see if their networks can handle large loads. In realistic scenarios, where you'll always have tens of thousands, hundreds of thousands, maybe millions of simultaneous calls and data sessions going across your network. So you want to be able to systematically load test in a controlled environment these types of networks to make sure that your network is behaving correctly. Um, so internet service providers and cellular service providers are a big customer base of ours. Also, equipment manufacturers. Equipment manufacturers are the ones making the actual infrastructure, the routers and the switches and the fiber optic cables and the legacy networks and things like that. So they need to also load test their equipment to identify performance thresholds and so forth. So a lot of different telecommunications equipment manufacturers come to us with load testing requirements. Finally, you have the customers of these service providers and equipment manufacturers. So for instance, government. The government can be a customer and they may be requesting a certain high-speed network from a service provider. And so but they can't just blindly trust the service provider. They have to independently verify that the service providers are delivering the network performance that they promise. So the customers of the service need to independently verify and load test their networks to make sure that they are getting exactly what they were promised. So military, civilian, um, emergency services, and so forth, they need to obviously load test their networks to make sure that they can survive, that these mission critical networks are performing up to standards. So these are just a few examples of the customers that come to us asking for load testing requirements. So the beauty of our solution is that we have a common framework called Message Automation and Protocol Simulation. It's a mouthful, so we abbreviate it as MAPS. And MAPS is our common framework, our software framework for emulating a whole bunch of different telecommunications protocols. MAPS is the heart of all of our protocol emulation capability. So you see on this screenshot all these different protocols. I kid you not, we support them all. And we can generate calls over all of these protocols. So over like a T1 or E1 network, we can do CAS, ISDN, SS7, and so forth. Over an analog network, we can generate analog calls like over FXO ports and so forth. Over IP, we can do VoIP calls using SIP or SIGTRAN or whatever. We can do calls over cellular networks. And not just phone calls, but all of the different interfaces in these core networks. So, like in a 5G core network, we can emulate these core network interfaces. So it's all done through maps, and this is like our engine. And then for whatever protocol you need, each protocol is a separate license. So we don't, so that it's a very cost-effective solution, because you may not, you obviously won't be interested in all of these protocols. You may only need a subset of them. So we license these protocols on a per protocol basis, and it's a very cost-effective solution. This is Mike will show you screenshots of the MAPS software. So I won't talk too much about it. It'll be kind of self-explanatory how you can invoke the software and kick off calls and things like that. Okay, so MAPS is a software framework, but we can couple it with our hardware appliance, which we call the high-density call generator. And so this is a custom-built rack PC. It has specialized network interface cards, customizable RAM, storage, disk write speed, optimized cooling. It's a custom-built, very powerful PC, and we build it for each customer specifically. So the customer tells us how much storage they want, how many calls they need to generate simultaneously, and we build the system accordingly. What's so amazing about this hardware platform is that it can generate a lot of different types of traffic over these interfaces. Not just phone calls, but it can send data traffic over IP. When I say data, I mean TCP traffic, for instance. We can simulate streaming services, such as meaning UDP sessions. So you can emulate phone calls or video calls and other types of streaming sessions. We can do fax emulation. We can do a lot of different types of data and video and voice traffic with this customizable hardware appliance. And well, we say here TDM analog IP wireless. So we design the interfaces specifically for what type of network you will need. I also want to mention, because this is a custom built solution, we have a couple different form factors for it as well. We can put it in a rack mount solution so that you can rack mount it and leave it in a network room or in a lab environment. But we also have a portable, what we call a lunchbox type solution. We put this in a nice Pelican case, and it's very portable, very easy to carry around, take out into the field, unload it, kick off calls, pack it up, or store traffic, pack it up, take it out to the next field site, and so forth. So this is very flexible. We have portable and rack mount form factors, and we have we can actually stick up to 12 high performance network interface card ports on the device. So here I think we're showing 12 10 gig Ethernet interfaces on the hardware appliance. But if you needed 1 gig, we can do 1 gig as well. In our latest version of this hardware appliance, we can we can emulate up to 200,000 simultaneous calls. So we use the 12 gigabit Ethernet ports or 10 gig Ethernet ports, and we can get up to 200,000 simultaneous calls with one single appliance. You can also use multiple appliances and control them through a single script to generate even more calls. So it scales even beyond 200,000 calls. So that's a little bit about our capability. Like I mentioned, we can generate a lot of different types of traffic. We can generate traffic over IP, and these protocols can be SIP, RTP, MSRP. We support all these protocols in order to generate VoIP calls or like any other specialized implementation of VoIP, like next generation 911 calls, ED137 calls in the air traffic domain. So all these different types of specialized protocols going over VoIP, we can do it with the hardware appliance. We can send pre-recorded video files, voice files. We can send fax. We can when we send these files, and when we send all this packet data over the network, we can also introduce some impairments in that traffic, intentionally introduce impairments in case you want to test how your network or your device behaves when it receives impaired traffic. We can dial any digits, tones. We can generate tones. We can do instant messaging sessions, and so forth. We can place two of these systems end to end to fully test a network path. So one system can be in city A, another system can be in city B, and you can be testing across that wide area network to see how the wide area network performs. So we can be at both ends of the network. We can send calls from one system to the other. We can measure, okay, we sent 100,000 calls. How many calls were successful? How many calls failed? How many calls were dropped? And so on and so forth. So we can do all that type of analysis. I obviously won't spend too much time on this slide right here. I know it's an eyesore. I just want to briefly mention that we support a whole bunch of different voice codecs. And so we have the whole list here. We have the whole list on our website. Pretty much any codec that you need, we've got it. Okay, so I did mention T1 and E1 networks. We have specialized hardware that can connect into T1 and E1 networks. So instead of Ethernet ports, we now can place T1 or E1 ports into our custom-built PC, or both. You can put T1, E1 ports. You can put Ethernet ports. You can put a combination. We can do a lot. So we can actually put up to 8 T1, E1 ports in a single appliance. And so and remember, each T1 or E1 has multiple time slots, so you can kick off hundreds of simultaneous calls onto a TDM network using this, what we call the octal card, which just means 8 T1, E1 ports. So these are embedded PCIe cards. We put them into our rack mount PCs. We do have more portable form factors like our T-Probe. Some of you are familiar, I see, which has, again, T1, E1 interfaces. Also has other interfaces on it, datacom interfaces, FXO and FXS interfaces, VF interfaces, and so forth. So when I said earlier we can test over all of these different networks. This is what I mean by that. By using a mixture of T1, E1 and analog and so forth. If you need to kick off hundreds of analog phone calls, meaning FXO, 2-wire, we have a solution for that. We couple our custom-built PC, rack-mount PC, with our channel bank, and the channel bank breaks out. And the way it works is that the rack mount PC actually has our T1 card in it, and the channel bank breaks out the T1. You see the T1 ports here. So the T1 connects between the channel bank and our server, and the channel bank actually breaks out those T1 ports into physical. Oh, sorry, breaks out those T1 time slots into physical analog ports. Each T1 has 24 ports, so the channel bank can break out a single T1 into 24 analog ports, and so on and so forth. So I think we're showing a system with 4 T1 ports. 4 times 24 is 96. So you can kick off 96 analog phone calls with this one single channel bank. And again, we can scale up even higher if you needed it. So we provide this whole solution. We provide the cables, the T1 cables, the 2-wire RJ11 cables, and you can test your PSTN or analog network and load test it. I'm not going to spend too much time on this next slide. It's okay. Basically, I just want to say we can test over SONET and SDH networks. We can test over fiber optic networks. As you know, SONET and SDH can be channelized, meaning you can stick T1s and E1s into these OC1, OC3, SCM1s, OC12, SCM4 pipes, and so we support that as well. We can generate all these traffic flows over fiber optic networks like SONET and the SDH. I just want to mention fax. We'll show some screenshots, but we can do fax over IP like T38 or pass-through fax emulation. We can also do fax over analog 2-wire. We can do fax over 4-wire, and we can do fax over TDM. So we have fax capability over all of these different networks. You can send these fax calls. We can do multiple simultaneous fax calls. Each fax call you can send like a different TIFF image and so forth. And you can do the analysis. I sent the fax call. Did I receive the fax call? Did the fax call go through? Did it get dropped? Was it a failure? Did the image come through? All that type of stuff. Okay, so now I will turn it over to someone much smarter than I am, and Mike will continue with the rest of this slideshow and go a little bit deeper for you. Go ahead, Mike. Thank you.
Thank you, Vikram. Yeah, so next we'll talk about this packet load appliance. So the appliance that Vikram had mentioned earlier is called the MAPS HD generator. That's meant for RTP traffic generation. So voice traffic over RTP. This packet load is designed for generating data traffic into a cellular network. So we generate the GTP protocol. GTP is a GPRS tunneling protocol. Essentially, it carries data traffic between a user equipment, such as a smartphone, and the core network. And using this device, we're simulating actually both ends of the connection in the GTP tunnel. We can generate the GTP control plane. So that's done by the MAPS application. It takes care of the control plane traffic. So that's signaling involved to set up a GTP tunnel. And then also this box will generate the user data traffic. So the actual the mobile data that goes into a cellular network. That's called the user plane traffic. So with this device, we can go up to 100,000 user endpoints. And we're simulating data traffic, things like web browsing, video playback, anything like that. So essentially, that's sort of a PCAP playback. So you can actually use your own custom traffic, load it into this box, and then we'll simulate a sort of a real life mobile network with all these data traffic going back and forth. There's a 1 gig version of this box and a 10 gig version of this box. And with the 10 gig version, we can get up to 40 gigabits per second of data traffic. And you see there are 4 ports Sort of on the right side, there are 4 ports. 2 of them are simulating a client side, and 2 of them are simulating the server side. So we're doing sort of interactive client-server traffic exchange to simulate a real-life network. There's a user-friendly interface. Everything is configured very easily. You can adjust the traffic type dynamically, so bandwidth, latency, packet loss, all sort of things that you can control through the software. There's also scripting that we can do, so you can do custom test scenarios, and you can automate a lot of the different scenarios that you want to test. Okay, so here's the sort of the overall traffic capabilities and performance that we can do through all of our different maps applications. So with RTP traffic generation, Vikram sort of touched on that. We can now get up to 200,000 concurrent calls. This is SIP. So for example, here, this is with SIP signaling and RTP traffic. So that's a huge jump from what we were able to accomplish before. Before we were at 64,000, and now we've gone up all the way to 200,000. So we're pretty excited about that. So the 200,000 also, so this is for UDP traffic. For TCP traffic, obviously it'll be a little lower. When we can sustain 800 calls per second during call setup. For video traffic, we can do 10,000 concurrent calls at 100 calls per second. And then if it's SIP plus MSRP is instant messaging that's used in the 911 emergency network. For that scenario, we can do 500 concurrent calls. So next, the GTP mobile traffic, which I just touched on with the packet load, we can get up to 100,000 concurrent calls. These are sort of HTTP-based traffic that's encapsulated inside of the GTP tunnel. And we can also do SMS traffic simulation inside of a cellular network. So for 3G, 4G, 5G, for different protocols there. So this is based on the number of transactions per second. Essentially, this is only signaling that's involved. There's no actual voice traffic there when we're sending SMS. So for that, the calls per second that we can sustain is pretty high, 5,000 for over the map interface, 1,500 over GSM and UMTS. So that's 2G and 3G networks. For TDM traffic emulation, so we have maps obviously for SS7, ISDN, GSM protocols. When we use these applications with the Sonnet Expert platform, which is the Sonnet SDH device, we can get up to about 7,500 concurrent calls using 252 E1s. So that's 252 E1s that's being broken out of a single STM4 pipe. And then for CAS, it's a little more process intensive, so we're limiting it to 8 E1s up to 240 concurrent calls. So now we'll give a brief overview of the MAPS sort of user interface. So as Vikram said, MAPS is the common framework that works for all of our protocols that we support. It's a GUI application, first of all, and it runs on Windows. So Windows 10 and up or Windows Server 2016 and up. It's the same look and feel across all of the MAPS applications. For this particular case, for the webinar, we're going to focus on the MAPS SIP GUI. So anytime you open MAPS, the first thing you'll see is the testbed setup. This is where you sort of define the different parameters that you want to use for your for the node that or for the device that you're simulating. In this case, there's a end user configuration, which is a set of profiles, which where we define the different SIP user endpoints that we want to simulate. So obviously for each protocol, there's going to be a slightly different version of this testbed setup, but sort of the idea behind it is the same. The testbed setup is where you define this kind of information. So RTP core address is where we want to, which IP address we want to use for simulating the RTP traffic. and so on. So this is a look at the user agent profile. So this profile was defined previously in the testbed. Inside of this profile is where you define the unique information for each user that you're trying to simulate. So in this case, you'll see that there's 10 different profiles here. Each profile is essentially, you can think of it as a unique user agent in the SIP world. So you have a contact address there that basically says, who I am in the SIP network. The address of record if you need to register this user agent to a registrar. The to address is where you want to send the call to. So information that's pertaining to each user, we define it inside of this user profile. And pretty much all maps applications have its own set of user profiles that you can define to define each unique endpoints. And so on the left, we're showing 10 profiles here, but you can easily create hundreds or thousands of different profiles. There's a tool in the GUI that lets you create profiles pretty quickly. Okay, so then in the Maps application, there's a global configuration section. So these are parameters that are accessible for all of the calls that you generate. So things like the call duration, intercall duration, things that apply to all scripts, we define here. Including timers for the protocol. You can. There's also randomization parameters. If you're doing load generation, you can randomize call duration, intercall duration, things like that. So all of these are pretty much defining parameters that are accessible to scripts. Scripts are what we use to actually generate the call. I'll get to that a little bit later. But this is a global view where you can define these parameters. Okay, so here's a screenshot of the actual calls that we're generating. So you'll see here on the left side, there's a script name. So for each Maps application, there's a set of scripts that we provide out of the box, which essentially has all of the state machines that create the call flows. So you notice how to handle SIP calls in this scenario. It'll send the invite, know what to do when the 100 trying, the 180 ringing comes back. And it knows how to reply to that, set up the call. Once the call is set up, we can do all kinds of traffic, RTP traffic simulation. So sending voice files, sending tones, digits, detecting tones and digits, sending fax, and so on. To make calls, we use a script, as I said, and then we use one of the profiles that was defined previously in the user profile configuration. So you can select the script and profile and hit start, and that'll send the call out. So in this case, you see there's a bunch of calls loaded here. You can start all of those calls simultaneously. And then we show the message sequence for each of the call that we make. And then you can click on each of the messages there, and then we give you a full decode of the actual message content. So this window that you see here works for call generation as well as call reception. Call reception works a little differently. So if a call is received by Maps, it's actually automatically picked up by the application. So if we, in this case, if we receive a invite message, the Maps script engine will see that the invite came in. It'll look at the request URI, so it'll see who the call is addressed to. And if that address matches one of the entries in the user profile that you had defined, it'll start the call automatically, load the appropriate profile, and then answer the call. So all of that on the answering side, everything is fully automated. Okay, so the previous slide was talking about call generation. So that's sort of an easy place where you want to just make 10 or maybe 50 calls. If you want to go up to thousands of calls, there's a different module that we use called the load generation. Here, it's meant for generating bulk calls for an extended period of time. So that on the top there, you see there's a total calls to generate number. If we use an asterisk there, that means there's no limit, so the calls will just go on forever. And then a max active calls is sort of a limit that we can provide to say how many concurrent calls we want to generate. And then the user can provide a call rate that we want to use to set up the calls. So for example, you use a fixed rate of 100 calls per second. That means you'll keep generating 100 calls a second until that max active calls number is satisfied. And then there's also a few different distributions that we support. Fixed will be just a fixed call rate. And we see that there's a uniform normal distribution, step, ramp, sawtooth. So there's lots of options there that you can use, so you can clearly define how fast you want to ramp up calls or how fast you want to tear down calls, things like that. There's also the option of defining a stop time. So if you want to just run the calls for, let's say, an hour, 10 hours, there's the options to define that right there. If you check that box, then you can set the number of days, hours, minutes that you want the test to run for. And then to actually make the call, it's sort of the same idea. There's a script that you select, and then there's a set of profiles that you select, just like in the call generation screen. Okay, so these are the different call results or statistics that we provide. On the left, we see the call graph. So it'll show you how many total calls we made, how many calls are active, how many have been completed. And then there's a pass-fail criteria that we show there. Pass-fail is defined in the script itself, and the user have sort of control that you can define what constitutes as a passed call and what should be a failed call. In general, we say a call is passed if the signaling messages are exchanged to actually set up the call. So at call connect, we say that the call has passed. Or you could define it so that you can say that the call is passed and you want to maybe perform a path confirmation test. And we can declare that the call is only a pass if it succeeds the path confirmation test. So it's all fully definable in the script. The script is, going back a little bit, the script is a GL proprietary format, but it's easily accessible, it's easily readable, and you can modify it to create your own scenarios if needed. So on the bottom there on the left, we have the call graph showing you calls per second, simultaneous calls, and on the right there is a pie chart that shows you the call success ratio, how many calls passed and how many failed. Okay, and then there's some additional statistics that we collect for all of the messages that were sent and received during the entire load test process. You'll see here there's the count of how many 100 invites that we received, for example, and then how many messages were sent. If there's problems sending the messages, it's also a retransmit count. So for example, if a message was sent, but we didn't get a response back, then we have to resend that message. So that's the retransmit. If that happens, that count there will show you how many times we had to retransmit certain messages. And then in terms of logging, there's 3 logs that's provided in the Maps application. Event logs and error logs are logs available or that are created by the scripts themselves. And again, it's user customizable, so you can define what you want to log in the event or error log. Typically, the event log will show you sort of the call progress information. And again, it's user definable in the script. We typically just log things like the call, if the call was placed, if it was answered successfully, and if there's any problems with the call, we'll show that in the error event section. So in the example there's some errors that we're showing as an example of a session creation failed, meaning that there was an issue creating the RTP session, and then 4XX failure message means a call was placed, but then it got rejected with a 480 error message. So things like that are collected in the error events. And then captured errors are sort of problems with the systems itself. If there's problem with reserving a RTP port or a UDP port, for example. Things like that would be thrown there. So those are system level errors that we collect there. Okay, so in addition to what we talked about, maps can also work with voice quality testing. So voice quality testing is a separate application that we have. Basically, when we run our maps calls, again using SIP as an example, we can be at both ends of the call. Right? We can be the the user agent client or UAC, or we can be the user agent server that's on the other end that's answering the call. Once the call is established, we can send and receive voice files from both ends. The file that we send will be called a reference file. And the file that gets received on the other end, we consider that as the degraded file because it passes through a network, so there may be some degradation to the voice quality. Once we have those two files, we do a comparison that analyzes both files. There's two ITU standards that we support, PESQ and POCA. Those are pretty much the widely adopted ITU standards that analyzes voice and gives. So essentially, it'll analyze the voice and give you a score ranging from 1 to 5. That's called a mean opinion score, and that basically tells you how good the audio quality is. So as we do these load testing, we can have calls that are also performing voice quality tests, and you can kind of see, what the performance is, what the voice quality is, and whether there's any correlation between the number of calls that you have and then whether that actually degrades the voice quality. So that can be that's easily integrated with all of our maps applications that we have. Okay, so here we're just going to show a few screenshots of the different traffic types that we support. In this case, this is a SIP call with a fax simulation. For fax, we have pass-through fax and also T38 fax. Both are supported for SIP. And then this is just showing the fax events that are happening as it's performing the fax exchange. Again, there's full decode of all of the messages that are received. Yeah, and then in this case, we're logging some of the events, fax events here. You can see in the event log that shows you each step of the fax transmission and reception process. For fax, for both TDM and for VoIP, we can receive the fax, and then there's also a separate application that we have that can actually analyze the fax quality, the received fax quality, the image file versus the file that was sent. Okay, here's a screenshot of the call generation and reception using the MAPS APS. The APS is the analog phone simulator, which is that channel bank that Vikram showed earlier that has the 96 FXO ports. So here we're showing you, so there's a script that does the place call generation, place call, and then there's a script that does the answer call on the reception side. For each script, there's a associated FXO line that you assign with it. So in here, you'll see that it goes from pretty much line 1 to line 96 as the name of those profiles. And then here we're showing you in the message sequence there, we're showing the call sequence of the generation side on the right side there, and then the reception side on the left. So when we do call generation, we go off hook, look for dial tone there on the place call side. If there's dial tone, we dial digits, look for ringback tone. When the ringback tone happens, on the place call side, the answer call side will be getting the ring signal. And once the ring signals have been confirmed, we go off hook and then we perform a path confirmation test between the two endpoints. And that's what that we have shown here. Same for this is the SS7 call generation and reception. So we're just showing you there the IM message that we sent from the generation side that gets received on the reception side, and then the whole exchange there, the address complete and the answer. And again, so when we click on each message, there's a full decode of the actual signaling message itself. So you can easily debug what's, if there's something wrong with the call flow, you can easily go into the message and then take a look and see what went wrong. Again, in this case, we're doing a sort of a file playback and recording on both sides. So that gets done as there's in our traffic in the profile there, we can select an option where we are just automatically sending and receiving file as soon as the call is established, and that's what's being shown there. And once the call duration is satisfied, we'll release the call, and then if you're making multiple calls, it'll automatically start the next iteration. Yes, and then this is sort of the same idea there for the ISDN call. We're just showing you the call setup process there. Okay, let's go to the next one. CAS is a different protocol that we support. CAS stands for Channel Associated Signaling, and it's actually sort of the underlying protocol that we use with our MAPS APS application. So both APS and CAS are sort of they're similar products in that we're using signaling bits to set up the call. In this particular case, we're showing a R1 call flow. With CAS, we also support MFC R2 and a few other protocols there.
Okay, thank you, Mike. So we just have a few slides left. We just want to mention that everything you just saw in the graphical user interface is also doable from a Python script or a Java script. So you can use scripting to do everything that you could from a GUI, but you can also use scripting for more advanced scenarios and more like automated testing type scenarios, repetitive testing, and so forth. So you can imagine scenarios like if you want to kick off calls every single hour. You obviously don't want to log into the graphical user interface and click start every single hour. So you can use a Python script to do that for you in a simple loop. So like that, we support Python scripting, Java scripting, and I should also mention that you can run the scripts from anywhere on the network actually, and they will talk to the MAPS server. So the MAPS server is running on our hardware appliance or on your PC, but it can listen to commands coming from elsewhere on the network. So you can run the Python script locally on that machine, or you can run it from elsewhere on your network as long as there's just a simple IP connection. Then the client PC running the script can easily talk to the server in order to kick off the traffic. Without going too deep into the weeds, these Python scripts are pretty easy actually to use. We provide a bunch of sample scripts. We can also help you if you have any sort of advanced testing scenario. We can help you write these scripts. And so forth. So we provide a lot of customer support. We provide user manuals, API manuals, and things like that so that you can edit these scripts as you wish. So that's just a simple screenshot that you see here. So that concludes our webinar. Thank you all very, very much. If you haven't already, please subscribe to our newsletter. We put out weekly newsletters talking about all of our latest feature enhancements and so forth. You can also email us at info@gl.com and we'll get in touch with you quickly. We look forward to hearing from you and have a great rest of your day. Thank you.